Today we study X27NQ entropy. It is a very short version. The ideal gas equation is PV equals NKBT. We'd like to compute the differential of kinematic thermodynamic variables. Uh, However, among PVT, only two of them are independent. So we'd like to consider the dependence of the three thermodynamic variables. So first of all, when we compute the total differential of a product AB, then it is simply by applying Leibniz rule, we find it is equal to AdB plus BdA. Because we first would like to remove the dependence on T, so T can always expressed in terms of PV over NKB. Therefore, the total differential of T is assuming that the number of particles is fixed. So it is over a constant factor 1 over NKB. And it is multiplied by PdV plus VdP. All right, so we like to divide this equation by this expression. Because they are the same, we divide the left-hand side with NKB T and the right-hand side with the PV. So they are the same. In that case, over a factor, this constant factor cancels, and the left-hand side, it becomes dt over t, and the right-hand side is dv over v plus dp over p. So they are all differential of logarithms. In case we'd like to make use of the P's dependence on temperature and volume, then we can express this one as a dp equals constant vector and differential of t, and because it is 1 over v, we have a differential of 1 over v is 1 over v squared dv and multiplied by t. Again, we divide both sides by p equals nkb, pv equals nkbt can be expressed in terms of p equals nkbt over v. So we divide left-hand side with this and right-hand side with this. Again, over a factor cancels, everything becomes like that. So we can compare the final result, but they are equivalent. The sign difference is because of the exchange of left-hand side and right-hand side term. In a similar manner, we can compute the volume to be nkbt over pressure, and in a similar manner, what we obtain is very similar, except that the appropriate replacement. Again, we divide both sides by v equals nkbt over p, and this one becomes dv over v and dt over t and dp over p. Again, we move everything all together on the left-hand side. We will find it is very simple to find this kind of expression. So we recall the PV equals NKBT. And actually a constant value NKB equals to T over PV, or 1 over NKB equals to PV over T, something like that. And then we take the total differential of this constant. So 0 is a total differential of PV over T. Okay, so we can compute this total differential in a similar manner. Eventually, these three expressions are all equivalent. All equivalent. If I move this one to the left, they are equal. And again, if I move this one And here it becomes this. So everything will be the same. Okay, the nature depends on the fact this is a constant. This is a constant. This one is a constant. So because it is constant, a 0 is a dp dv over t, and this constant is divided t tv. What's that? Differential of something divided by x. It is a total differential of log something. So as a result, if I have some correlation equation involving some product or reciprocal and some powers, a x, a, y, b, z, c, something like that, it's constant. In that case, we can always simplify this differential in such kind of manner that involves logarithms. Okay, that's it.